Hello and welcome to the second part of my video series, The Making of a Super Battleship. In the last video I covered how I break down a model for 3D printing. I also showed the process of designing a rangefinder. If you haven't seen that video, please make sure to check it out. In the meantime, I have gone ahead and designed all of the other rangefinders. I also successfully printed them. So today we can go into another subject, the superstructure. And as with the rangefinder, it is always advisable to break down a complex structure into smaller manageable parts. So let's do that first. I'm going to mark the part that I will model first. It looks like a really complex shape, but it's really not, as you will see. All of the other parts I'm going to ignore for now, like the mast and all of these smaller structures. So with that out of the way, let's get into the modeling process. For the beginning, there's not really that much to comment on. I brought in a cube, scaled it up and extruded some stuff out here and there, and yeah, pretty basic stuff. Where it did get interesting though was this concave surface, and as you can see I wasn't able to get it right on my first attempt. But after a little bit of tweaking here and there, the result was quite satisfying. Now as a final step, let's move in these vertices and we can go on. Here I added 2 edge loops which I would need later, only to realize that it was too early to add them, so I had to delete them again. Because it turned out they would cause some issues when I want to bevel this one edge here, which I should have known before, but well, sometimes you just screw it up. So I deleted them. And because of all of my failed attempts, this curved surface ended up taking me 5 minutes. So I will speed up the footage here significantly. The main tower at first glance looks easier than it is. The side of it looks like a perfectly flat surface. And it is, but it is also rotated in the Y and Z axis. So I need to get the orientation right at first, and then cut out all of the redundant geometry. Now, this part also took me quite some time. And there were even 2 failed attempts which I didn't record. So if you're wondering how I ended up with this arc, that's the reason why. I simply failed to press record. Finally, adding a subdivision surface modifier to add more geometry to it. In the beginning I did have my doubts if the superstructure could be printed in one piece, so I brought in this cuboid, which represents the build volume of my printer. And I didn't expect it at first, but the entire superstructure fits into it. I want to show you another challenging aspect of creating models for 3D printing. If you're wondering where we are here, we are at the aft section of the superstructure. Here, to be exact. You might realize that the geometry looks a little bit weird when I subdivide it. It might be a little bit better visible in this zoomed in perspective. Let me mark it in the model. It might only be barely visible, but the geometry gets pushed in like this. Here you can see it a little bit better. If I turn off the subdivision, it looks like this. This one edge goes straight down. But when the subdivision is activated again, it gets pushed in like this. This phenomenon always appears at the point where surfaces with different curvatures are joined together. So this is something to be aware of. I probably wouldn't run into this problem if I used CAD software, but since I use Blender, I have to find a way around this. I want to go a little bit into how I join parts together that are printed apart from each other. We have here the aft section of the superstructure with all the platforms for AA and rangefinders. And we have the main element of the superstructure. In the printed model, these will be different parts, but somehow they need to be joined together. And it seems natural to slide the aft section into the main section like this. And as long as you only need to connect flat surfaces, that's not really a big deal. It gets difficult here, where you have these beams that are intersecting with a curved surface. So first I have to cut out some geometry from the beams so they don't intersect with the main superstructure. And the remaining geometry from the beams needs to be cut out from the main superstructure. And this is what the result would look like for one of them. This already is very complex geometry, but wait until you see the next one. This is an interesting one. You have two beams intersecting at an angle of about 100 degrees. And those intersecting beams intersect with the main superstructure. From the top it looks clean so far. But if we take another look from this perspective, you can see that I did cut away a little bit too much. But don't worry, I did fix it later, because as a German engineer I cannot possibly let that slide. And the university might even be tempted to revoke my right to use the professional title engineer. So yeah, I did fix it. I promise. And all of the other connections need to be modeled individually. And the thought process of how I'm going to do that actually takes more time than modeling it itself. So I would say for every minute I actually do stuff, I have to take another minute to think about how I'm going to do it. So this is the final version. Well, not entirely final, some minor details are still missing. It looks very complex, and it is, but I'm confident that I can print it in one part. So let's move around a little bit and look at it from different perspectives. I'm going to show the rangefinders as well now. I think it looks pretty good so far. Of course this part is hollow, because resin is expensive. I did use Autodesk Mesh Mixer to hollow it. Well, it wasn't really that easy. First I had to export it using a certain scale. Then the model needed to be repaired. I used Prusa Slicer for that. From Prusa Slicer I brought it over to Mesh Mixer where I hollowed it. And then bringing it back into Blender, again with a certain scale. Because in Blender I have a life-size model. For the rangefinders I have used different ways of attaching them to the superstructure. The smaller ones will be attached using magnets. The slots for them I have marked here. And of course the counterpart on the rangefinders. For the bigger ones I designed a mechanism that doesn't require magnets. All of the details have a minimum thickness of 4 mm, or at least all of the details that need to support themselves. Otherwise they would be quite wobbly. So, but that's it for now. I really don't have that much more to show for. I'm going to continue working on the Satsuma, and when I have enough content I will upload another video. In a previous video I mentioned that I will be working on 2 other battleships as well. For one of them I think I have enough content to make another video. So make sure to look out for it. It's going to be something about another German battleship. I'm also experimenting a little bit if shorter videos will be well received. So if you enjoyed this content, let me know in the comments. If you didn't, also let me know. And I hope to see you again very soon.